This is Claire Sturgill speaking, and this is Team Biotech's presentation on our capstone project, PDBMine-Data, a web application to let users explore and analyze the structures of proteins. These are the members of the biotech team. Dane Hooks did a lot of our back end. Niharika Pandala did a lot of our front end and design work. JJ Sati did data analysis and visualization. Claire Sturgill, that's me, did the analysis of protein structures based on chosen angles. And Jenna Pahowski did our testing and helped out in other areas of the web application. So our objective for the PDBMine-Data project was to make proteomic analysis with PDBMine easier by both streamlining and extending the use of the PDBMine service. Basically, we take the phi and psi angles of proteins that have already been classified, their structures are known, that are stored in the protein data bank. We use this to model a protein sequence with a currently unknown structure, and then we want to be able to present this information to users in a easily understandable visual format, and to allow them to save and move between previously analyzed sequences.
PDBMine-Data and why is it important? To give a quick background, the cause of any disease at a very cellular level can be traced back to the misfunction, hyperfunction, and dysfunction of one or more proteins. A structural understanding of the protein directly correlates to how it functions in the body. So understanding the structure-function relationship is necessary to develop effective medicine or vaccine. Our website, PDBMine-Data, analyzes protein angles, we'll also refer to that as torsion angles, to determine its probability using clustering and likelihood using kernel density estimation, KDE. This computational approach is the most cost-effective and time-efficient when compared to traditional methods of classifying protein data, like X-ray diffraction and NMR spectroscopy, where NMR stands for nuclear magnetic resonance. PDBMine-Data and who could make the best use of it. It will definitely be an evident tool on the platform of research and development in protein structure prediction. Though this might sound niche, it targets major communities like bioinformaticians,
Alert from Brave
computational
browser.
biologists, big data analysts,
April's honey giveaway.
epidemiologists, biochemists, biosystems analysts, mainly the healthcare department, which is a huge industry. Further, we can talk about physicians in the department of immunology, proteomics, microbiology, and genetics. So the impact is huge, and it is one of its kind. PDBMine-Data and when can it be useful? 3 general applications: vaccine development, preventive medicine, and developing effective medication. If there were to be a best time to use, it would be the current unprecedented times of COVID-19 because of 2 major reasons. One is that we have already seen a SARS pandemic before in the year 2002. And we know now through research that it shares a sequence identity of 79% with COVID-19. That is a very strong point where PDBMine can help out. And 2, we have seen that the virus is highly transmissible and is mutating at a very fast rate. So when we have such a ever-evolving virus, it's important that we have technology that is cost-effective and time-efficient to isolate genome and study these emerging pathogens and its mutation for faster development of vaccine. And what best can PDBMine-Data offer than this?
This is Jenna Pahowski, and PDBMine-Data will have a direct impact on the research done in our client, Dr. Valifar's lab. There is no substitute for PDBMine-Data and is the first of its kind. Currently, users have to download and analyze every single protein individually, and there are about 150,000 different proteins. They would then have to develop and execute a Python script that performs these data calculations. Currently, all data analytics and summary is performed in either Python, R, or MATLAB. However, this kind of data requires a level of expertise and skill most users do not have. All of this data quickly becomes very costly, time-consuming, and ineffective to calculate. There are many goals of PDBMine-Data, one of the most important being determining the possibility and likelihood of protein structures. With detailed figures such as kernel density estimation and cluster analysis as shown below, researchers are better able to understand the biological functions of protein functionality. PDBMine-Data also helps to summarize the torsion angles to create a PDB file for further investigation. The user can select and try different combinations for the predicted model by selecting the hand-picked torsion angle for each residue of the protein sequence. They can then download these angles as a PDB file to render its structure using other applications. A demo of this is showed later in the presentation. Some more goals of PDBMine-Data are that it offers an efficient way to access multiple PDBMine queries with one particular PDBMine query. We touched a little on how it improves the size and complexity, but the size issue is addressed because oftentimes many queries contain multiple redundant pairs of torsion angles or data points too similar to other points within the data set. PDBMine-Data reduces the size of this data, which in turn reduces the complexity and leads to faster processing and visualizations. The complexity issue is addressed by how PDBMine-Data provides condensed figures to complement the huge amounts of data the software receives. The ultimate goal of these figures, usually in the form of Gaussian KDE and cluster algorithms, is used to better determine the possibility and likelihood of protein structures.
So let's get started. Let's go ahead and create an account. My backstory could be that I'm a bioinformatics researcher and I'm interested in looking at all the torsion angles for residues out there. However, the process of calculating and looking at these angles is computationally expensive and time consuming. And this tool is a great way of avoiding that. So let's go ahead and log in. As a user, I want to create an account. So I'm going to register. I'm going to my account credentials. So say new user 99 and my password. Let's go ahead and submit it one more time and click on submit. All right, great. So my account's made. Let's go ahead and log in now. New user 99 and my password. And we're logged in. So let's go to projects now. Let's create our project. Projects. And we'll create a new project because we don't have any submitted from before because this is a new account. New project, and let's use our parameters we saved from before. So demo 123. The description will be something simple, so let's have it as this is a video, exclamation points, and our window sizes from the slides will be 2, 5, and the sequence will be DAYAKAKD. This is all very straightforward, so let's go ahead and click on create. And there we go. So it'll tell you that your project has been submitted successfully with this nice little splash screen. And if you go to projects, it'll show it right here. Keep in mind that you have to wait for a minute for the data to process completely. So if we click on it immediately, it will take us to a screen showing us that the results are still processing. For the sake of the video, I've already went ahead and created the results in a different page. So I'll pull those up and show the features in the results.view page. So if I go here, you'll be presented with this screen, with this sort of data. And clicking on each different letter will give you the appropriate plot for that residue. The same applies to window sizes. If you go into window sizes, just clicking on 2 and 3, 4, and 5 will update the plot with respect to window size and residue. These 3 buttons are associated with these 3 buttons down here. With select chosen, selecting on different data points will have that specific point's information shown down below. If you click on select a cluster, right here in the download section, that will download a CSV file for all points within that cluster. If you click on all points, that will download a CSV file containing all points within the plot. Now clicking on collection, the yellow div right here, you can assemble a list of points that may interest the user. So clicking on different data points will build a small list. And you can download the list using the collection button in the download section right here. And download a CSV file containing all the data regarding these points. And lastly, we have a PDB file generator right here. And this is the main feature that interests our client. Clicking on each file or each data point will add the respective torsion angle to the associated letter. Clicking on each one will update the appropriate row, and it's required that the user submits one from every residue out there. If the user does not submit a residue from every angle, the user will be given a warning saying that you must select an angle in every residue. So we're going to go ahead and select an angle from every residue. Only 4 more remaining. And one from right here. And let's go ahead and generate that file. It'll automatically download a file that can be used to